All right, we are live. Welcome, everyone. We'll give folks a few minutes to join in. And while you're waiting, let's just type in the chat, where are you dialing in from? I'm currently in Hunter, New York. We also have Leo in the chat, who will be actively moderating the textual discussion in today's webinar. Cool. So I think we'll get started, and at least with intros, and then we'll let more folks join in. Hi, everyone. Again, my name is Gleb. I am CEO and founder of Datafold. Previously, before Datafold, I was a data engineer at 3 different companies, including Lyft. So at Datafold, very excited to be building tools for data practitioners and tools that I would very much love to see in my personal workflow. I'm still doing data engineering because we are a Series A company, so I'm writing SQL at least twice a week. And here with me is Nick Carchedi, our product manager. Nick, I'll let you introduce yourself.
Thanks, Gleb. Hey, everyone. Nice to meet you. My name is Nick. I'm a product manager at Datafold, and I've been working in and around the data space for quite a few years now, in education, starting companies, like sort of big data product companies. Most recently, working in reverse ETL before joining Datafold, and I've been with Datafold since early this year.
Awesome. Cool. So today we have exciting agenda. We'll talk about some of the newer functionality on Datafold, as well as give everyone an overview of what Datafold is. If you haven't heard from us in a while, and we'll go through a high-level overview, and then we'll pass the mic to Nick, who will actually show a live demo. So we'll have some hands-on demonstration today, which is exciting. So a quick reminder what Datafold is. We are a unified data quality platform. Our goal is to automate all the tedious work and error-prone work related to ensuring quality of analytical data. And that means we're plugging into the data practitioner's workflow in a few different contexts. So in terms of how we think about our product, it's actually a combination of different tools that can be roughly centered around 3 areas. One of them is CI/CD testing, so helping data teams detect and prevent data quality issues when they make changes to the code before those changes make to production. The second area is around data monitoring and observability. So being the first to detect, investigate, and resolve those issues. So data monitoring, column level lineage, and other areas fall into this category. And this is actually the area of focus today for us. And what Nick will be demonstrating is some of our new functionality around monitors. The third area is automating migrations. So if you are in the process of adopting a new data stack or migrating certain workloads to a new warehouse or a new framework like dbt, Datafold can help you automate code translation and validation. And we call Datafold a unified and proactive data quality platform. We try to give every word a meaning. So unified means that, like I said, it's a combination of tools that all under one roof help you ensure data quality across all workflows, production, development, and deployment, and across different stages in your data pipeline. And proactive also has meaning. So we really emphasize prevention over detection. We all know that data can be noisy, and if you just start applying anomaly detection everywhere, you will be just drowning in alerts and notifications. And so we really try to be proactive in helping you prevent data quality issues from getting in production in the first place, as well as detect them as upstream as possible in the flow of data. And the proactivity is based on the shift left approach from software engineering that we apply to data. And the shift left approach is something that is actually quite simple, right? If you think about the data quality issues and how we detect them, the rightmost way to detect them would be if our stakeholders tell us about that something broken. And that is clearly the worst possible scenario, because by the time our data users tell us about broken data, the damage is done, it's already too late, and we lose trust. So if we progressively shift it to the left, the next best place to detect data quality issues is with observability and monitoring. And that allows us to be the first to detect the issues. But what's even better is to be able to detect issues during deployment and development, right? So if we can detect bugs in the code before that code gets merged, then we don't have to worry about even detecting things with monitoring. But what's interesting is the shift left approach is not only about data quality, it's also something that helps us achieve other goals, such as increasing data engineering team velocity. Because if you don't have to spend time reacting to and investigating alerts all the time, then you have more time to develop. And if your testing is automated, then you have less time spent in back and forth in the code reviews. But the focus of today, as I mentioned, is data monitoring, right? Which you may wonder, like, Gleb shift left approach is kind of about before production, but how does it actually apply with monitoring, which we want to talk about today? So it turns out that we can also apply shift left to monitoring. And the way it works is, if we imagine how a typical data platform works, right? So we have this image, which likely is a simplification of what you actually have in a real world scenario, but let's say roughly it's true, right? So you have source data on the left, event streams, replicating your transactional stores, getting data from APIs, everything landing in the warehousing layer with some transformation layer on top, and then ultimately getting into the BI and data app layer. We can see that data flows left to right, right? We're all used to the concept of DAGs, and our dbt or Airflow DAGs are structured that way. And so in the production context, shifting left means detecting issues as upstream as possible in the flow of data. So for example, if you are replicating data from a transactional store into your warehouse, one thing you can do is check for anomalies in the warehouse itself. But a better way, and a more shift left approach way, would be to detect discrepancies in the replication process itself to answer the question whether the data actually lands in the warehouse. So again, shifting left is probably one of the core principles and most effective principles in data quality management. And what's interesting is we can apply it to the world of monitoring by focusing on detection of issues as upstream as possible in your DAG. I'll hand over to Nick in a second, but just to give you a sense of the types of companies we're working with, as you can see, these are select group of customers, wide range of teams from high growth startups to enterprise. We have a lot of customers in financial services and healthcare, probably because in those areas, data quality is of even higher importance than for an average data team, given the compliance issues. So with that, I'm going to pass to Nick, who will talk about our latest data monitoring functionality and the best practices for applying shift left in monitoring. Nick, take it away.
Thanks, Gleb. All right, so picking up where Gleb left off, I want to show a few slides to just give everyone some high-level context around how we think about data monitoring at Datafold. Just to give you the lay of the land, and then we will very quickly jump into a product demo, since I imagine that's what most people are here to see. All right, so at a high level, as Gleb already alluded to, data monitoring and observability are about detecting issues in your data and having them sort of proactively surfaced to you as quickly as possible so that you can take action on them. And we do this through a variety of different methods. We have 4 high-level monitor types in Datafold. And we'll talk through each of these in a bit more detail. But starting from the top and going down here, a data diff monitor takes the concept of a data diff, which is kind of where Datafold started as a company. It's our kind of core technology behind many different parts of our product. If you're not familiar with the data diff, I will also describe this in more detail in a minute here. But effectively, what this allows you to do is compare data in 2 tables that live in 2 different databases, and sort of ensure parity between those tables. And this is particularly useful when you're replicating data on an ongoing basis between, for example, a transactional database and a warehouse, or if you're maybe migrating data. So number 2 is a metric monitor. This allows you to track many different types of metrics in Datafold, and then do anomaly detection on those metrics, so you're made aware when something goes off the rails. 3 are what we call data tests. So these are effectively like assertions that you write against your data that surface problematic records, specific records in your data that violate your expectations in some way. And then finally, schema changes, detect breaking changes to schemas. So this could be columns added or removed, or data types changed, for example. So just zooming in on each of those in a little more detail here. So a diff monitor, again, for those of you who are not familiar with the concept of a data diff just compares the data that lives in 2 different tables down to the individual value level. So if you've seen a git diff, for example, you can just sort of take that same concept and instead of applying to code, apply it to the data itself, and that's a data diff. And I would say larger picture here is in Datafold, you can do diffs for tables that live within the same database, or you can diff tables that live in 2 different databases. And when it comes to monitors, it's really diffing across databases that's most interesting. You're moving data from one place to another on an ongoing basis, and you want to ensure that they're the same. And you want to do that continuously. So on the metric monitor front, I mentioned that you can track all sorts of metrics. We sort of distinguish between like what I'll call off-the-shelf metrics. So these could be table level metrics like row count or freshness, or column level metrics like what you see here, fill rate, uniqueness, cardinality, min-max, etc. Right, so those are sort of the off-the-shelf options. Or you can program your own. You can write SQL and create what we call custom metrics that might encode like your own business logic, and then again set up automated anomaly detection on those. And you can do that using our automated machine learning powered anomaly detection, or you can set sort of like manual thresholds. You can say, actually, like this metric should never be above or below this number, or should never go up or down by more than 20%. So it's quite configurable. Data test monitors, as I mentioned before, allow you to flag problematic records in your data. So you're basically writing assertions against your data in SQL. And then we flag those problematic records for you as soon as we find them, and surface them to you in a number of different ways. So we can show you a preview of the records of failure tests in the app. We can attach a CSV of them to, say, a Slack notification. We can even materialize them back to your warehouse if you want to have like sort of a feedback loop where you identify the problematic records and then go do something with those records a little bit differently in your warehouse. For example, maybe stop them from going to production. And then finally, we've got schema change monitors. This is pretty straightforward. As I mentioned, it's flagging column additions, removals, and type changes. And so we're basically snapshotting a table schema continuously over time, flagging when there's a change, but then also, conveniently sort of presenting a change log of a given schema that you can reference anytime in the product. I didn't explicitly mention this, but you can get notifications for all of these things anywhere you want, basically Slack, email, PagerDuty. You can even fire off webhooks, but we make it pretty easy to surface these when there are issues. Finally, I want to mention something we call monitors as code. So, some of our customers prefer to configure things in the UI, and we certainly like to believe we make it pretty easy to do that. But when you're configuring monitors at scale, you want to sort of spin up and manage like many of these. It can be useful to use what we call monitors as code, which allows you to configure everything that I'm about to show you in version controlled YAML files in, for example, a GitHub repository. So not only does this make it really easy to sort of bulk manage these things, we also provide some like shorthand. So you can say, all right, I want to spin up a schema change monitor for every table in the schema using like a simple wildcard syntax. In addition to that, you also get governance. So it's a lot easier to sort of track changes over time. If somebody wants to add or change a monitor, they've got to submit a pull request, and that gets reviewed. And so a lot of teams that we talk to like having that level of control or governance over their monitors, because it does become sort of critical infrastructure over time. Okay, I think with that, I will move on from the slides and show some specific examples in the product. Okay, so the first monitor that we're looking at here is a diff monitor. So up here in the top left, you can see that we're diffing between the same transactions table in two different systems, in this case, Postgres and Snowflake. And the idea here is, maybe we're replicating this transactions table on an ongoing basis from our transactional database into the warehouse. And these two data sets should match. They should be the same. And so we use a diff monitor to continuously compare the data in both tables and flag when there are differences. And so what you're looking at here is basically a history of monitor runs. And you can see going back in time here, we're looking okay, right? So we see the status over here on the left-hand side. We're okay. You will also notice that it says there are differences detected. Now, the reason we have an okay status, but there's differences detected, is because we've set a threshold. We've basically said, look, in some cases, we expect these tables to differ by a few records. But what we want to do is sound the alarm if they differ by more than 10 rows. So as soon as the total number of records different jumps from 5 to 11, we're now above threshold. Now we sound the alarm. And basically, get a Slack notification about this and come into the app. And then what's cool is you can jump into the data diff and actually see a summary of the specific records that differ between the two systems, again, down to the individual character level. You can also see sort of a roll-up of this information. You can see the number of records in each of the two tables. You can see, are there primary key differences? Are there null PKs, exclusive or duplicate PKs? You can look at, columns with different values and how many values within each column are different. So you can get a very sort of high-level bird's eye view look at things, or down to the, again, individual character level. How are these two tables different? And then presumably, somebody came in here and made a fix, or things sort of returned to normal on their own. We go back to an okay state, and we even get back to a situation where we now have 0 records different between the two, and we have sort of perfect parity between systems. And the idea is you would run something like this continuously. It would run, every hour or every day. The schedule is totally configurable. And that's how a diff monitor works. So again, this is particularly useful if you're replicating data between systems on an ongoing basis, or if you are migrating data from, say, a legacy system to a new system. Many times migrations take many months or even years to complete, and you want to sort of be validating data between two systems continuously during that time, so that finally, once you get to a point where all the data is moved, you can confidently say, all right, everything is the same, stakeholders are on board, and you can close the door on the project and move on. Okay, so now I'll move on to metric monitors. And as I mentioned earlier, we have a couple flavors of metric monitors. We have like sort of off-the-shelf metrics, and we have custom metrics. So what we're looking at here is a row count metric. This could just as easily be a freshness metric, or at the column level, we could be monitoring fill rate, uniqueness, cardinality, any of these things. But at the end of the day, what we get is a number, a numeric metric that we track over time. And we allow you to set up anomaly detection on that metric. So we can see here, this blue band is our automated anomaly detection, which we set up here. You have the option to, so this is fully automated out of the box, but you do have some configurability. You can sort of dial the sensitivity up or down depending on the signal to noise ratio that you're looking for, and that'll increase or decrease the width of the band around the data. You can see that when the data points go outside of our anomaly detection range, these red dots are alerts that would be sent. Again, Slack notifications, emails, PagerDuty, etc., whatever you prefer. You can also look at a table here, and so we can see, each row here represents a monitor run similar to the diff monitors. We can see when it's gone into alert state. We can see for every monitor run, what was the observed value of the metric, what was the change, both in absolute terms and percentage terms, from one monitor run to the next, and then what was the range of expected values. And so when the observed value is outside of the range of expected values, we get an alert. So this is an example of a custom metric. So in this case, we're looking at hypothetical net new accounts over time. Powering this is a SQL query. And you can see here, we've sort of run the SQL query behind the scenes and automatically determined, all right, you've returned a date column to us and a numeric column to us, and therefore these will represent the timestamps and the metric values for your metric monitor. We're plotting it here, but the mechanics are basically the same, right? It works the same way as the off-the-shelf metrics. We're tracking the metric over time. We're snapshotting it on a schedule, flagging when we have something that goes outside of the expected range. Now, conveniently, as I mentioned, you can also set manual thresholds here. So we could say, for example, we actually want this metric to always be below a value of 20. And then we can even preview what that looks like before we save our changes. So without sort of disrupting the monitor as it is in production, we can preview our changes and see like, okay, what would have happened historically had we had this maximum threshold of 20 here? Well, we can see that in this case, we would have had one alert on August 26th. Okay, and now this is sort of dialing up the complexity just a bit more. This too is a custom metric, but in this case, we're actually using a third column to group by. So we still have a timestamp, we still have a metric value, but now we're actually grouping by country code. So this is a hypothetical page views by country. And what's cool here is when you fire up automated anomaly detection, we automatically train the model on each group individually. And so, this data is pretty noisy because I generated it myself. But you can see that there is some seasonality in the data. So our machine learning algorithm automatically picks up on the seasonality and does account for it. But again, the mechanics here are the same. But many customers like this grouping functionality because when the metric does go off the rails, it sort of helps you get to a root cause more quickly. You can identify, okay, what are the subgroups that are sort of driving the change in this metric in an unexpected way. Okay, now this is a data test. So, this example is looking at a subscriptions table. And we're just trying to identify records where we have a negative price, which would clearly be unexpected. And so the way that you design these tests is you sort of take the inverse of your expectation. So if your expectation is that subscriptions should always be positive or greater than or equal to 0, we'll say, then you would want to flag records that are negative. So just write a query that returns records that violate your expectations. And then we run that query on a schedule, and we let you know when we find records that violate your expectations. So if we go back in time a little bit here, we can see on the 13th, we had an alert. We found one failed record, and then we can very quickly jump in here and see, okay, what was that record? Why did it violate our expectations? Well, we have a price of 0, which is unexpected in this case. We can download that as a CSV. We do materialize that back to the warehouse. And then as I mentioned, you also do have the ability to attach a CSV of failed records to the notifications themselves, whether that's Slack or email. Looking at another example of a data test here. This one's a bit different. This is flagging invalid emails. We're just running a simple regex against the data. And going back a few pages here, I'm not seeing any alerts. So what I can do is actually just filter on the status and see, okay, the last time I had an alert here was on the 14th. And that was the issue. Okay, finally, I want to look at a schema change monitor. So this particular schema change monitor is monitoring this signed in table. I'm just going to filter for alert status, and we can see, okay, back on the 13th, we had one column removed, this duration column. If I click in here to view details, I see a column by column comparison, effectively a before and after of this monitor run. So the way to think about this is every time the monitor runs, we snapshot the schema for this table, and then we do a before and after comparison. And so in this case, we see that we previously had this duration column in the data set, and then when the monitor ran this time around, the duration column was no longer here. We can see at a glance what is the column types in case there's a change there as well. And then at any point in time, I can also just jump in here and see what was my schema for this table at that time. So again, I think of that as sort of a change log for schema. One other nice thing is we do provide this lineage tab on all of our monitors that are linked to a specific table. And so when you have an issue come up, for example, the duration column is removed, you can very quickly jump in here and see, all right, what are all of the things that are downstream of not only this signed in table, but that specific column that may be negatively impacted. So this is column level lineage. If I click on a particular column here, I see what are the specific columns downstream of that one. Okay, I think with that, I will stop there and happy to answer any questions that Leo has not already answered in the chat. So I see a question. Jacques, if I'm pronouncing that correctly, please forgive me if I'm saying it wrong. Do you consider that the issues in real life don't really come as nice individual raindrops? They tend to be silent and then come in storms, and sometimes perfect storms, i.e., one metric taking many others south. Also, yes, absolutely. That is life. I think that's the nice thing about the automated anomaly detection is like it sort of catches the unknown unknowns. Like you're not sitting around sort of saying like, okay, I expect this metric to be between such and such values. Like Datafold, like you figure it out. Obviously, these systems aren't perfect. They can't possibly know all of the idiosyncrasies of your data, and so like the idea is you sort of set it up and let it run for a bit, and then you fine tune it over time. And we try to give you the tools to do that.
Yeah, I think also that's a great question, Jacques. That's why we embedded column level lineage as downstream impact into every monitor so that you can also see the impact on the downstream metrics, and that can help you correlate multiple failures and see what's the cascading effects of a particular alert. But overall, yes, this is probably one of the hardest problems of monitoring and data because everything is so tightly related. And so being able to understand which things are related and should be grouped together, investigated together versus are separate incidents, that's a big focus area for us to continue to develop as product.
So a question, a couple of questions here. So I'll start with Dylan or Dylan. Again, apologies if I didn't get your name correct. So when an upstream issue is detected and starts tripping alarms, what are the practices or processes built into your product for pausing or disabling or relaxing the alerts temporarily and then resuming once fully resolved? Yeah, it's a great question. So you have a few options here today. Like let's say you get a notification, one of your metrics that you're tracking has gone off the rails, and you're actively investigating, and you don't want to be getting alerts for that monitor in the meantime. So first thing you can do is you can simply flip a switch in the product and like disable that monitor temporarily while you're doing the investigation. You could also adjust the schedule again temporarily to sort of slow the pace of it while you're looking into things. As a PM, like I think one of the things I'd like to explore next is like having what I think you're alluding to here, which is like sort of like a snooze functionality, or the ability to just like temporarily disable or acknowledge an alert in a way that doesn't then require you to sort of like remember to go back into the product and like re-enable a monitor. So it's a great question. Do have tools for it today, but I think we can do better there in the future. Question from Kyle, can you run a data diff against a table? Okay, it looks like Leo has already answered this. Okay, see a thumbs up. Yes, Leo, thanks for mentioning that. So I did, like, in terms of sort of programmatic management of monitors, there's a couple sides to this. So one is like the creation, configuration of monitors can be done like really like nicely with the monitors' code in those like version controlled YAML files. But another way is like via our API. So like basically everything that you can do in the UI, you can also do via a REST API for monitors. Um, we're like sort of actively shipping improvements here. It's been a big area of focus for us recently. But that means like not only like creating and configuring monitors, but also like triggering monitor runs. So a lot of customers have said like, hey, I actually like don't want to run this monitor on a schedule. Instead, I want to like, wait for this other job to complete somewhere like in my pipeline, and then like when that completes, like fire off uh, an API call to Datafold to trigger a monitor run that corresponds to that particular table. And like that too is possible. Any other questions? See someone is typing, so we'll give them a chance to finish up.
I guess I'll like ask a question, Nick. How easy it is to POC monitors with Datafold right now?
Um, well, Gleb, it couldn't be easier. um, yeah, if anyone on the call is interested in trying out the product, please reach out to us after the webinar. We're happy to get you set up with a trial account, so that you can test out the product. I make myself available to customers pretty regularly to help them understand the different monitor types and sort of strategize like what's right for them, because obviously like you may not be accustomed to thinking about like data quality in terms of like the different flavors of monitors that we provide, and so we can help you navigate that as well. But we're happy to let
Yeah.
POC the product before you make a commitment.
Jacques asks a good question about the checking schema changes in APIs. So the way that we currently track schemas is based on the tables that land in the warehouse. So you can actually track the changes in those APIs indirectly. For example, if you use an automated process that changes the schema, and that schema is reflected in the schema of your warehouse, right? When it comes to actually tracking changes in the API itself, yep, that's something that's on the longer term roadmap for us.
Yeah, so just to add a little more color there, like we have a lot of customers who say like, look, we're ingesting Salesforce data via a tool like Fivetran into the warehouse, and like we don't control that data. Like that's the business, that's the sales team or the ops team that controls Salesforce, and like they're making breaking changes in Salesforce like all the time. Like they're constantly experimenting, and like those changes like trickle down into the warehouse, and depending on how you have things configured, like that might be like changing your schema like in the warehouse without notice. And as a data team, like you've got a lot of things running downstream of that Salesforce data in the warehouse. And so like the idea there is like, well, let's throw a schema change monitor on that Salesforce on that table as soon as it hits the warehouse, so that and run it on a frequent schedule. It could be every hour, so that as soon as that data changes, you're notified and you can coordinate with the relevant folks to make any adjustments downstream or ask the business team to revert the change if it's bad enough. Yeah, I'm not surprised to hear that's your story. It is definitely a common one. Okay, well, if there are no other questions, thank you everyone for tuning in to Datafold TV and for all the great questions. Please feel free to reach out to our team if you have any further questions or if you'd like to give the product a try.
Thank you, everyone.
Thanks, guys.